Dear students, Namaste, good morning. Now we are in the plane's fourth part. Already we discussed some theorems, that is the equation of a plane. There are four types, namely number one, the first degree equation. I am writing on the board, observe me. The first one. The first degree equation in x, y, z represents always a plane. Ax plus by plus cz plus d. A, b, c, d are the constants. It is x power 1, y power 1, z power 1. That is the first degree equation. That is the first theorem. Next, it is a normal form. Normal form. Okay, now normal form of plane. That is r bar dot n cap is equal to d, where d is length of normal. Okay, now and n cap is unit vector along the normal. Okay, now every time in the previous three parts, the three videos, I am explaining all these things because it is very important. Normal form means, suppose it is horizon, x-axis, y-axis, z-axis. A plane is like that. This is normal. Say it is OL. This length is d units. Okay, na? That is, you observe me. That is horizon, x-axis, y-axis, z-axis. Suppose a plane is a big pad, you take it. That touches x-axis at A, y-axis at B, z-axis at C. Then it is in the slope form, just like a triangle pad is there. From origin to that surface of a plane is OL, that is d units length. Okay, na? And n cap is unit vector along the direction OM. The n cap is a unit vector. Then this is the normal form of equation of a plane. Next, third one. Suppose a plane is like that and a vector a bar is given. Okay, na? Or otherwise, it is a perpendicular to the plane. It is a normal to the plane, you assume, whose DRs are L, M, N. Don't confuse. Sometimes we use L, M, N or DCs also. Don't confuse. These are numbers. DRs means direction ratios. Already we discussed. DCs is somewhat different, but notations we are using the same. Nothing wrong. Okay, now. And there is a point A, it is x1, y1, z1, and we take a point, a general point x, y, z. Then its equation is equation to plane whose diagonals of the normal of the plane is L, M, N, and passes through a point x1, y1, z1. This is the coordinates of a point. Suppose 1, gamma, 2, gamma, 3, just like. Then it is x minus x1 L. N of y minus y1 plus n of z minus z1 is equal to 0. Because the diagonals of AB is nothing but x minus x1, y minus y1, z minus z1. So it is one set. And diagonals of normal is one set. They are perpendicular. L1, L2 plus M1, M2 plus N1, N2 diagonals. That sum of product of those numbers L1, L2, this is L2, M1, M2, N1, N2 is equal to 0. Why? Because it is 90 degrees. So through that one we can get this is also the equation of plane whose dias of normal of the plane is given and which is passing through a point. Then this is the equation. Suppose it is 1, 2, 3, assume that it is 1, 2, 3, a point which is passing through that point, plane is passing. And this is somewhat 3, 5, 4, 5. Then what is the equation? 3 of x minus 1 plus 4 of y minus 2 plus 5 of z minus 3 is equal to 0. Okay, now this is one. But it is somewhat different. The second one, normal form. It is very clearly given. Find the equation of plane whose length of normal is d is equal to some 5 units and n cap is well given a vector n cap is suppose I plus j plus k by root 3. You assume is n cap because the unit vector, this is a unit vector. The equation of plane whose length of normal is 5 units and n cap is unit vector along that normal is, that equation is r bar dot n cap is equal to d. D means here it is 5. R bar dot of n cap is I plus j plus k is by root 3 also is equal to 5. So clearly we can write it as r bar dot of I plus j plus k cap is equal to 5 root 3. Okay, Nana? If we are going to, if you solve the problems in the exercise, very neatly it can be understood. Right? So the first degree equation, normal form, and this third one is dias of normal and plane is passing through a given point. Now fourth one, it is also clearly given, that is a plane is passing through 3 points 1, 2, 3, B is 4, 5, 6, C is 6, 7, 8, just like the show. A plane is passing through these 3 points. Then equation to plane is, equation to plane is, what is the determinant of x minus x1, y minus y1, z minus z1, x1 minus x2. This is y1 minus y2, z1 minus z2, x1 minus x3, y1 minus y3. It is z1 minus z3 is equal to 0. So here it is. This is x1 y1 z1, x2 y2 z2, x3 y3 z3. Now you tell me. It is x minus 1, y minus 2, z minus 3. 1 minus 4, 2 minus 5, 3 minus 6. And again 1 minus 6, 2 minus 7, 3 minus 8 is equal to 0. This is nothing but x minus 1, y minus 2, z minus 3, and this is minus 3, minus 3, minus 3, and it is minus 5, minus 5, minus 5. Okay, now you see, minus is common in the first row, second row, and third row also. So it can be written again, it is as x minus 1, y minus 2, z minus 3. It is 3, 3, 3, 5, 5, 5. Okay, now again we take 3 is common, 5 is common. It is x minus 1, y minus 2, z minus 3, 1, 1, 1, 1, 1, 1, like that. And you can expand it. Simply I am taking some example. You expand it, you can get one equation of plane. Okay, na? So there are 4 types we discussed. The 5th one is there. Okay, na? Now. Observe. 5th one. This is intercept form. Intercept form of plane. Okay, now, if the intercepts of the plane be A, B and C, then equation to plane is x by A plus y by B plus z by C is equal to 1. First of all, what is intercept? This concept is also in first PU, that is intercept form of straight line is there. Now we are going to solve this one. Suppose this is x-axis, y-axis, z-axis and horizon. Okay, now a plane is like this. Suppose a plane it cuts the x-axis at A and y-axis at B and z-axis at C. Okay, now this is the intercept A, where the plane cuts the x-axis horizon to that point is the x-intercept, that is A, and this is B, where the same plane cuts y-axis at B, capital B. So OB is the distance, y-intercept, and this is C. Okay, now. Then what about the coordinates of capital A, 0, 0? The coordinates of 0, B, 0. You know it well. The coordinates of C is 0, 0, C. Okay. Now the plane is passing through 3 points. Directly we are not given the 3 points A, B, C. We are given only the intercepts. Through that one we are achieving capital A, capital B, capital C. Those coordinates are A, 0, 0, capital A, B, 0, B, 0, capital B, capital C is 0, 0, C. Now the required plane is passing through 3 points. Required plane is passing through 3 points, capital A, B and C. Now equation to plane by using the fourth problem, just we solve. Then the determinant of x minus x1, say it is x1, A, y minus 0, z minus 0, x1, y1, z1. x1 minus x2. You see, this is x1, y1, z1. This is x2, y2, z2. x3, y3, z2. You assume like that. A minus 0, 0 minus b, 0 minus 0. A minus 0, 0 minus 0, 0 minus c is equal to 0. It is x minus a, y, z. A minus b, 0. A 0 minus is equal to 0. Okay, now you see, this is x minus a of minus b to minus c, bc, minus 0 to 0, 0. Minus y of row and column, this minus sc minus 0. Z of this is 0 plus a. Okay, now If you delete the z round column, it is n 0 0 minus of minus n plus n. Okay, now it is clear. So it is BCX minus ABC plus ACY plus AB, that is equal to 0. Okay, Nana? You see, that implies BCX plus ABZ plus AC y is equal to ABC. That ABC is sent to that side. That is BCX plus ACY plus ABZ is equal to ABC. On both sides we divide with the ABC itself. That is BCX by ABC. ACY by ABC. ABZ by ABC is equal to 1. Okay, now BC cancels X by A. AC cancels Y by B. AB cancels Z by C is equal to 1. Okay, now which is intersect form of a plane. Okay, enough? So there are 5 types we discuss. 5 theorems. Not needed to learn the proofs of the theorems, but the concept and the formula is must be known. Okay, now go ahead. Next we are going to solve the problems. Just pause.
Pass అయిందా మకినా
ఇక్కడ నెంబర్లు పోతుంటే నిలిచిపోతుంది. అదే నెంబర్లు పోతుంది కదా కింద 15 నిమిషాల ఇంకా పోతాను అది.